Hi guys, and welcome back to Aid's Workshop, and this is going to be part 3 of building the Stuart Models S50 steam engine. So yeah, I'm sure you've all seen part 1 and part 2 by now. I want to address, before we start with this episode, a bit of criticism that I've got, or had, from somebody who's obviously watched the video, and they seem to think that I'm trying to make some sort of educational or instructional videos. That's not the purpose of Aid's Workshop. The sole purpose that I share all this on YouTube is just to show me having a bit of fun in my workshop. And if people want to watch it, that's up to them. This is not a definitive how-to channel, but it does give people some ideas of how things can be done and different setups and what have you. Now, I'm obviously open to criticism being on YouTube. I mean, it's going to happen. I mean, people say, well, use that bald old fat bugger with no teeth. And whatever, I got thick skin. Anyway, what I was criticised for was my clamping method in part 1. And around the 30-minute mark, I showed a clamp which people were saying, oh, it's insecure, it's not the right way to do it. Why are you teaching and showing people this? As I said, that's not the purpose of this channel. As far as I'm concerned, for the operation I was doing, it was perfectly safe. I'll show you the setup. I replicated how I had it set up, so I'll show you that first. So yeah, I've just put a clamp in roughly where it was during the problematic scene. Yes, I know I need to sort these clamps out. They're a little bit rusty. I don't use this particular large one very often, and yeah, so it doesn't get handled, doesn't get oil on it. Need to sort that out, but that's my own housekeeping issue. Anyway, the issue was that I had the clamp on the very top step, not overhanging the top, but on the very top step in the serrations on the block, as you can see here. In fact, it's on different parallels, so it's actually on a bit more of a downhill angle than it was, but it was perfectly level on the top step. Yeah, if you're going to set a clamp up, always bias it so that the heel is level or slightly higher if possible than the piece being clamped, but level or slightly higher, rather than, you don't want to be clamping on a lower surface. Anyway, so yes, I agree this is not best practice, but for what I was doing, which was purely drilling a 3.1 millimeter hole through the casting here, this was before it was screwed down, the base was bolted down, I had to clamp this end and the far end. It's only just nipped, that's all it needed, was for drilling this hole. So it was a 3.1 mil drill, no heavy milling operations, anything like that. So loads on this clamp were going to be next to nothing, and it wasn't even tight, it was just nipped down, that's all it needed. Okay, so let me show you a better practice that I could have done had I known that these people were going to be taking a look and criticising. So yeah, with these step blocks, they will mate up. So let me just undo that one. So what would have been better would be to put a partnered step block like that. And to sit the clamp, in fact that's too high for this particular instance. There we are, slightly downhill. Put my little piece of packing back under, a little piece of leather, fake leather, and put the clamp back into position. I'm not a big fan of this, but I'd rather put a piece of packing underneath the base of the foot, or the foot of the bolt, but that's sort of best practice. This works well. A better practice, I'll show you that, would be, I haven't got a piece of steel that's appropriate here at the moment. Let me see if I can find something. Alright, for instance, piece of packing, this is just a piece of scrap aluminium. Something like that might have been, under these circumstances, slightly higher. Don't know if you can see that. Let me just spin my viewfinder around. There we go. Yeah. So something like that would be the ideal setup. Of course, the added bonus is you get a wider footload, and I can actually have it over the T-slot. It wasn't in this position originally. So anyway, that's addressed that. Yes, I know that there are better ways to do it than have it on the top. But basically, to you guys, I'll tell you, one of the subscribers actually mentioned it to me, and this came up, the criticism came up on the Model Engineers Workshop forum. Somebody sent me a link to it, and thank you for that. showing this whole malarkey that was going on. There were a few supporters saying it was perfectly safe and that real world, that's how things are done, and that the operation I was doing wasn't milling, I wasn't putting any great loads on it that was going to cause the block to kick out, all that. But anyway, okay, we got that skeleton out the cupboard. I do know the right way to do it, and I don't always do it. Hence why I say this is not an engineering training board how-to set of videos. It's just me in my shed messing about, having fun. If you don't like it, don't watch it. So another thing that comes up regularly, people are sort of almost insistent sometimes that the gib on my x-axis is loose. Because when I'm winding the crank handle and the camera's pointing down the line of the table, they can see the table doing this. Now, my camera tripod sits on the wooden floor of my shed. The camera itself has an image stabilization built into it, so that anything that's moving, it will try and keep it still and keep focus on it. So it's stabilization, as in by the very nature. If there are static objects in the shot, they won't move, but it will try and keep moving objects still through the field of vision, so as to get a better shot. So what happens is, as I'm cranking the handle, as you can imagine, like this, I'm biasing the floor in the shed, which has got a bit of sponge in it, and I'll see if I can replicate the shot, but it comes up quite often. I'll see if I can replicate it. I don't know whether that showed up or not, but if it didn't, I'll see when I come to the edit. If it didn't show the table or the impression of the table being loose on the gibs, I'll find an older clip and insert it somewhere around here. Anyway, so moving on from all that anyway. I got thick skin, guys. I'd take no flaming notice of it, if the truth be known. Set of 7BA taps. I actually had 6BA and 8BA, so I ordered a set of 7BAs. Again, on well, cheapest high-speed steel ones I could find, from Peninsula Steam. I've got some, I think these were the 7BA screws. I bought some of those. I'm just going to try and match up the head sizes, but I may fit these in place of the cast ones. These might be the screws I need. I'm just going to check that the heads are pretty much the same diameter. I guessed it's 7BA. And for screwing it down, it was as cheap to get a bag of 100 as anything else. I've got some 4BA bolts to replace the M3s. So that's that. Yeah, not much else has come. Oh, a mystery thing. What is in here will come to light later in the video, as you'll see what it is and what it's for. So, I won't show it at this stage. Let's get straight on and do some machining then, guys. So now that I've established I'm going to go off the centre line of these. These are 3 or 4 thou oversized at the very top. And if I come down 3 or 4 mil, they're like 10 thou oversized. So I'm going to machine the outside of these. The drawing doesn't call for it. But to keep, so I've got a reference I can come back to. I'm going to machine the 2 outsides of this, square and parallel. And that gives me something that I can keep coming back to should I lose my datum. So that's the plan next. I'm going to get a cutter up and I'm going to machine just a tickle off the outside of both of these. Maybe 3 mil deep, something like that. Just to blend them in to get them as something I can come back to. So that's giving me a reading of 540 thou offset. So, yeah, I think we can run a cut along there. I've locked Y. A bit of a skin on it. I haven't got enough to sort of dive under the skin. Okay, I'm going to offset 540 the other way. Where are we? Let's just see where the touch off happens on this side, just to double check myself. Okay. Let's go for 530, I think. 530. That's better. So there's a scratch off that side. Okay. Oop. Move that spanner out of the way. Hit the camera. And 530 this way as well. 746. But I am central about. So yeah, I'm not worried about that. There's 4 thou. No problems. No problems whatsoever. So the next thing I'm going to do is, I've already got a datum for the hole. Where are we? You can see where I'm pointing, the hole here. I'm going to put the 4 bolt holes in on this, and I'm also going to work out a distance where the 4 bolt holes are going to go. So that's straightforward enough to plot where they are, and I know where they are from central. So I've still got 0 as my datum in the center. So I can offset the same both sides. I think the centers are 9/16. So I'll be going 932 left and right, and the correct distance down. So we'll have a look at the drawing and I can show you that. So off my centerline datum and distance from the crankshaft, I've just plotted out and just by hand brought a center drill down and marked 3 little holes, as you can see, or 3 marks. This one's worked out slightly to the left in the casting. This one here slightly to the right in the casting, but pretty much central. That's pretty much central. And this one looks way off to the left in relation to the shape in the casting. So there is enough meat there to get the clearance hole in. I'm worried about what's going to happen underneath, but I've had a quick look at the drawing just to see how it plots out, and I think we're going to be okay. So these 3 holes are clearance on 7BA, which is, bear with me, is 2.6 millimeters. So I got a center drill with a 2.5 pilot on. I'm just going to center drill them just so that the pilot enters, and then I'll get a 2.6 mil drill and drill these 3 holes. So that's the rear 2 drilled. Back to my center of those 2, they were 1/2 inch, well, inch centers, but 1/2 inch is my center hole. You just bring the DRO back to the 0. It takes me back working in the Imperial. I'm pretty much finding out how rusty I am. And this is 7/8 of an inch, which is 875. Which is 876, 875. And that's the 3rd hole. Okay. Right. So swap over for a 2.6 drill now. So 2.6 drill. Looks like butter, that. No need for any lubricant or coolant. Small holes like this, as I said, there are 2.6 holes in there. I've got my center drill. I can basically just pop the center drill in the hole and just deburr the top surface of the holes just with my fingertips, and that will just put a tiniest of little champers on the top of the holes. So yeah, they are deburred. So 4 holes in here. So I've just gone back to my 00 datum, which is this cross here, and I know that the first hole where the beams sit is 1 inch and 7/8. So I'm going to show you how I swap back and forth between absolute and incremental. So from a 00, this mark here, I'll move along in X 1 inch and 7/8. Then I'm going to swap across to absolute, because to incremental, sorry, from absolute, because the dimension between these holes is from this point. I could add the two together, you know, to give me a distance in X. But if I can reset a 0 on that center point, you can see 9/16 either side. So I'm basically resetting a 0, 0 here. And I can go 9/32 either side. Then I can step along 1 inch and 15/16 and do the same again for these two holes. So I'll show you how we do that. So I've got the plastic screen on this cover on my DRO. I suppose I can't take it off without disconnecting the power lead, and I don't want to lose my datums for the moment, so we're going to leave it where it is. But I think if I'm filming from now on, I think it's a lot easier for you to see if I remove that. So anyway, from my 0, 0, 1.875, so let's get to that figure. Oh, it's hard to get it on that button. Yeah, okay, it keeps wanting to jump to a couple of hundreds out. Okay, not to worry. So what I do now is I'll swap to incremental from absolute, and then I'll reset X and Y to 0. Now I can, at any time, I can go back to absolute, and that tells me where I am in relation to the world, but back to 0, 0, so my datum can be around that point. So I'll take you back to the drawing, and I'll show you where I am now with a 0, 0. So I'm basically on this crossroads here, in the center of here, with a 0, 0. So I can basically step in and out in Y by 9/32, half of what the distance is. And then I can come along by the 1 inch and 15/16 and pop the other two holes in exactly the same fashion. So we'll do that next. So 9/32 is 2812. So moving Y to 281, 281, 1. Yeah, close enough for that. Okay, oh, I need to find out what size holes these are. Quick look on the drawing, coming around behind the camera. They are 4 holes tapped per 7BA. So they're going to be 2mm holes, 2.05. Well, I haven't got a 2.05 drill, but I have got a 2mm. Oh, I'm going to have to find a smaller center drill. I found a center drill with... Oh, it's not in the chuck properly. I found a center drill with a 1mm pilot. Try that again, shall we? That's better. So I'm on the 281 offset. Oh, dearie me. Okay. 281 the other way. Go a little deeper there, I think. And we're all right. Okay. And distance between centres is, looking back at the drawing, 1 and 15/16. So I think what I'll do is I'll pop the tapping drill in now before we move across. Faster. Okay. So I need to know the depth of this hole. And it says 5/16 deep. So, and that's the depth of the thread. It says 4 holes tap 7BA by 5/16 deep. So I got to tap them at 5/16. I probably want to go 3/8 deep at least to be able to get the full engagement of the thread. So I'm going to come down to touch. There. Set a 0 on my quill DRO. What am I in? Am I in metric or am I in imperial? It's 375. Drill down till I'm 375 out deep. Being very gentle with this, using the quill. Can you imagine breaking a drill off? No, I can't imagine breaking a drill off. Okay, so move across 1 inch and 15/16. So that is 1.937 and a half. 937.5. Okay, so exactly the same. I've just put a 3/8 ball nose cutter up. It makes it simple for my maths than converting metric cutters and what have you. I'm on my 00 datum point, and from the center line, the datum, which runs right down through the center here, it's given a distance for this space of 5/16. Or with a 3/8 cutter, I've already come 3/16 out from center. So yeah, another 2/16 or 1/8 of an inch, so I can offset a finished face on here, which will be 1/8 of an inch back in Y. So that's simple. Yeah, I just need to work out a depth now for, that I need to run this ball nose down to have a clearance on the crank part, which is going to go here. So even though the cutter's not quite long enough to do it all in one pass, I'm going across. I'm at the 125 now. So that's finished the dimension off. Okay, I'll just run back across it, and I think what I'll do then is step down to the final depth. It's another 200 thou deeper it's got to go. I'll probably drop down 50 thou at a time and just do the last 200 thou, working my way back and forth. So I'll calculate the depth, and I need to make the overall width of this correct now. There's a washer, 5/8 diameter washer, which goes on this side behind the flywheel from the looks of the drawing. So yeah, I need to drop down by 5/16 with the plain part of the cutter below the center line to be able to clear the washer, and obviously there'll be a little lead out rad. So again, the cutter's not really long enough. I'm just going to come across to a touch. I'm going to get a clean up, and then we'll have a measure. So that's not far off parallel, that side actually. Right, okay. I'm just going to take, I don't know, let's have a think, a few thou. I'll run that cut across, and I'll have a measure, give myself a ballpark of where we're supposed to be when we're finished. The overall width of this is, according to the drawing, 1 inch and 7/32. So I'll work out what that is. Because I'm not used to thinking in English or in imperial. 1 inch and 7/32. Let's have a look. Where's 7/32? 1.2188. I'll write that down. 1.2188 is my finished size. So we'll have a measure across there now, and I'll know how much has to come off. So I've just taken a scratch off, given it a measure. It's got to end up at 1.2188. We'll call it 1.219. And at the moment, it's measuring 1.263. So there's pretty much 44 thou to come off. And if I were to take that, let me just grab a rule. It's going to pretty much remove this sort of detail of the casting completely. Now there is a washer which sits on here, which the drawing shows as 15 gauge thick. So I have got my old Zeus book here, which I'm sure has got standard wire gauges and what have you. So I'll have a quick look. It's possible that I can make the washer thinner that goes behind the flywheel, and that will allow me to leave a bit more meat on here. So we'll try and split the difference, find some middle ground. So I just found my reference for 15 gauge. It's 072. This needs 44 thou off it. What I'm thinking of is if I make the washer 22 thou thinner, make it 050, I only have to take 22 thou off here. So that's what I'm going to do. So I've taken as much as I dare off this space. I'm not going to take any more. I want to leave this feature. So the size as it stands, and it should be 1.219, and it's actually 1.234, we'll call it 234 and a half. So it's it's oversized by, let's say, 219 to 23. Getting a slightly different reading. Oh, hang on, I'm dropping into there. 234 and a half is 235. So yeah, 235 from 219 would be 16 thou, shall we say. Is that right? 219. Let me just get this right, otherwise I'll get all sorts of comments. So I've just done a quick sanity check. Okay, the drawing called for 1.2188 width, thickness across the two bearing housings. Right. The actual measurement I got is 1.2345, which is a difference of 0.0157. The washer that goes on the outside is supposed to be 0.072. If I take the extra thickness I've got across my bearings from that, I now know that the washer is going to be 0.0563. So that's what I'll be aiming for when I make the washer. So I've amended the drawing accordingly. So when I do make the washer, I won't forget of the little change I made. So it's just a case of keeping track. If something's not quite to spec, then you need to alter something else or fix something else. You need to know what you're doing and amend the drawing. So that's what I've done. So when I come to make the part, it'll still be back to within spec. So I'm about to call it an evening or a night or a day. Call it a day, let's say that. So I'm going to put everything away. I want to turn my DRO off, but I don't want to lose my datum. So what I've done is come back to 00 on the DRO and locked the table off. So pretty much I can switch off the DRO. Next time I come back in the workshop here, I can switch the DRO back on, set 00 in absolute and incremental. I know where I am. That's my 00. Nobody else is coming in here but me. Nobody's going to mess with it. Happy days. There we are. So yeah, you can turn the DRO off without losing all the information. Just come back to a known point or a datum point, ideally. Almost like a home point. So yeah, that's what I'm going to do. And I'm going to call it a day for this evening. It's probably not the end of this video. But yeah, I can have another little look tomorrow. So we haven't been on the lathe for a while. I got a piece of 1/2-inch bronze up in the chuck. This didn't come with a kit. This is a piece that, well, basically I bought for making these little bearings. But always handy to have a bit of bronze lying about. I think it's about 6-inch long. So I've just given the lathe a clean. It was, well, it doesn't look spotless now, but I can assure you I had to clean it. I think the word is for shame's sake. It was, yeah, in a bit of a mess. The last bit of work I did on it was turning in a bit of steel and a bit of 01. and there was great mountains of swamp. It was dirty, it was oily, it was in a mess. So right, as per usual, first step, face off. So I'm looking for a 5/16 diameter, which is going to be a, let's say, snug fit in the bearing housings for the crankshaft. I'm going to use a bit of Loctite on it, but a snug fit would be nice to start with. So where are we now? 1/2 inch. So we'll call that 12.7. Right, I'm looking for around the 8mm mark. So I'll take 1/2 mil aside. I put a nice new tip in for this. As always, it's one of the tips I use on aluminium. Or the aluminium tips, I should say, or the tips made for aluminium. There we go, let's have that off. Right, so out with the mic now, let's see where we are. So I decided to do things properly, and I'm actually using this set of Stuart number S50F small hole gauges, going to measure the bore that the reamer left and see what we've got. Yeah, so 3125, so I want 300 to 400 thou one. So just grab that one out of the packet and we shall gauge the hole. So yeah, I like these. These were a gift from a fellow YouTuber, well maybe 12 months ago now, from Kimber, which is, to shout out his channel, it's Kimber Zelic. Kimber, Zelic is Z-E-L I-K, I believe. It might be I-C-K. Apologies if I got it wrong, but I'm sure you'll find him. Smashing guy, just starting out on YouTube, just starting out in the world of machining, from a family of engineers, toolmakers, machinists, shall we say. Never done it himself. I believe he was a lorry driver of some description, but he's decided in his at this stage of life to take up engineering. So he's got a mini lathe and what have you, but yeah, that's Kimber Zelic. So Kimber, they are being used, and thank you very much once again. So, in with the gauge. Gently, gently, tighten up the screw on the end, keeping it as square as I can see. That feels about right. Okay, so now with a mic, got my Mitutoyo mic. I'm expecting a couple of thou over. Three one 3-1. So yeah, about 800ths over. I think 3133 I'm getting on the little friction symbol. Let me make sure. Yeah, probably a thou over. I think I'm going to aim at a little bit tight. That's 3124. Let me do it again, just to make sure I wasn't being heavy-handed or anything. That's a nice bit in there. Three one 3-7. 3139. Okay. I think I'm going to aim at just over 313. Okay. Mic's the wrong way around for you to see it. Three 141. I think that could be almost a fit there. I'm going to move my hand wheel very slightly. Nothing showing on the DRO. I think I'll run that again. See where we are. See if I can. It's going to feel weird. 31295. Okay, so can you pick that up? Yeah, I think you can see it. 0.31295. So I think we're going to be, at worst, a gentle press fit. I'm going to try it, and if it doesn't fit, it's going to have a polish. So I need, or in the finished part, I need a quarter bore up the middle, quarter reamed, or a good fit on the crankshaft. So I think I'm going to get the piece of material that's for the crankshaft and mic that up. I've got a feeling it's undersized. So I got the piece of material. 24815. 2481. Let's come up the other end somewhere. 2479. 2483. It's not perfect. It's thou and a half to 2 thou underneath. 2489. Yeah, thou to thou and a half undersize on the nominal quarter. I'm going to have to think about this as to what clearance I'm going to use. If I were to use my new quarter reamer, I pretty much know it's going to cut a thou over a quarter, sort of 251. So I'm going to have 2 to 2.5 thou oversize on the shaft. I have got an old quarter reamer which cuts a couple of thou undersize. I think I'm going to use that instead of my new reamer, with an idea that I can always open it out a bit bigger at a later stage, but I can't make it smaller. And I think this needs, I may swap out this piece of material that they've supplied, and I'm pretty sure I've got some quarter silver steel, which is 250 thou. So I may not use the piece of material that was supplied, or I may. Let's see how it works. So I can see this being one of a few that I make to get the size right. I'm just going to take a mil or so off the end. Okay. I'm going to put a tiny chamfer. I've got a brand new tip in my tool here. There we go. Yep, I may need to have to put the reamer through again. I'm probably going to do that anyway. And I'm going to part it off. I've had a quick loop, I've had a quick look, and I want about 9 mil. So let me just grab a rule, line up on the end. There. This is going to be oversized and machined on the inner face afterwards. So that's a 0. I'm going to come back 9 mil. At least I would if I was in Imperial. Just swap over, okay. About there. As I just said, this is going to be machined off afterwards. So I've had a bit of fun and games with that. I started again, made 2 more. The first one didn't quite fit, but my size of 313 does fit nicely. Yeah, as you can see, and there, yeah, just the sort of fit I was looking for. So we got that bit right. I took the rod supplied with the kit. This mics up at, let me just make sure I get it right, 2479, 2483, something like that. I've just deburred the end and polished it with a bit of emery in the lathe. And it fits in there lovely, and you think, yep, we've got that. Let me bring you in a bit. Look. You can hear it. Although it runs nicely, it's, yeah, no good. Okay, so I thought, well, let's see what bore I've got. See if I've oversized reamed it, because it feels more than 2 thou. So again, taking a little bore gauge. That's a tiny bit tight, so I'd imagine I'm about 1/2 thou smaller than that is where I should be. Can you see the mic? Not really, my hand is in the way. Right, okay, I think you can see it now. So the bore there is yeah, not bad, maybe 1 thou up. So that wobble mostly, I think I'm looking at 1 thou clearance anyway, that wobble mostly is this piece of bar. Yeah, alignment wise, no problem. So I thought I had a piece of 1/4 silver steel in stock, drill rod, silver steel, whatever. I've just mic'd this up, and I don't know what it is. It was a viewer gift, but it's micing up at, yeah, 256. So 255.5. Leaves me material on here to machine down, so I can have a look at the drawing. Well, on here to machine down, I can have a look at the drawing. I'm going to do a little experiment. I'm going to machine this down to 250 on the button over, you know, long enough, whatever that is, 40 mil, even if I got to do a bit of polishing. And I'm just going to try it as a gauge in these bushes to see what size I'm looking for. And then I may buy a piece of silver steel, the right size, or I think it's about 2 1/4 long with a thread on the end. This has got to be. I may make it out of this rather than order a piece, but we'll see how it goes. So the mystery item, a piece of 1/4 silver steel. It's 01 or drill rod, as some people know it. So I'm going to cut myself off a piece at 2 3/4 long, and we'll try that in the bearings. So we're all degreased. Okay. Oops. Let me just push that back out a bit, went in further than I wanted. I want to turn that now. Just grab a rule. Ooh. Ooh. Flush there. Don't need a great deal. Give them a turn. There we go. So we'll leave those now to go off. Happy in the knowledge that our shaft is going to fit. So I think that's about it for this one, guys. A new milestone was reached, I think last weekend, something like that, of 8,000 subscribers. So we finally crossed over from the 7s into the 8s. And I think as we stand at the moment, we're about 8,200. So we've had a lot of new subscribers since I've been doing this little steam engine project. So welcome to you all. Anyway, thanks for watching, guys. Thank you so much for subscribing. And we'll see you all very soon. Cheers now.